Okay, this is going to be, I'm going to do question B here, but I'll do question B with long division instead of synthetic this time, okay? So same idea, part B1, like the first part of B, is to actually find the remainder. So what I'm going to do is, again, let's say let f of x represent the function, so 12x cubed minus 2x squared plus x and minus 11. And so what I'm going to do is actually evaluate the function at this time. This is going to be negative 1/3, right? To identify what the remainder is going to be. So we're going to get 12 multiplied by, that's negative 1/3 cubed minus 2 times negative 1/3 squared plus negative 1/3 and minus 11. Okay, so we're going to get 12 multiplied against negative 1 over 3 cubed is 27 minus 2 times 1 over 9 and then minus 1/3 and then minus 11. Okay, so this is going to be negative 12 by 27 minus 2 over 9 minus 1/3 and minus 11. So by I need a common denominator to be able to do any of this. So this is going to be negative 12 over 27 minus 9 goes into 27 3 times. So that's going to be 3 times 2 on the top, which would be 6 over 27. Minus 9 over 27 because 3 goes into 27 9 times, and then minus, so there's going to be a big number down here on the end. We'll leave it as 11 for a second, see what we get. Okay, the 27 might be reducible with something if we see what ends up happening here. So negative 12 take away, oh look at that, negative 12 take away 6 is going to be negative 18, take away another 9 is actually going to be negative 27 over 27. Minus 11, which is negative 1 minus 11, which is going to be negative 12 remainder. Okay, so what we can do now is actually do the long division. Okay, so I'll do an example of the long division as well. So what we're going to do is take 3x plus 1, and we're going to long divide it into the polynomial. So 12x cubed minus 2x squared, 2x squared plus x minus 11. Okay, and so we always kick these problems off the same way. We do, how many times does 3x go into 12x cubed? So that's going to be 4x squareds, okay? And you'll notice I'm keeping the x squared terms stacked up, okay? And then once I have that first initial move, I'm taking 4x squared and basically distributing it on top of the binomial out front. Okay, and so we're going to see minus 12x cubed plus 4x squared. And then you do the subtraction. So 12x cubed minus 12x cubed, that's 0x cubes. And then negative 2 take away 4x squareds is going to be negative 6x squareds. Then you drop this down, plus x, okay? And basically the problem starts over again. So how many times does 3x fit into negative 6x squared? That's going to be negative 2x. And so you take negative 2x and redistribute it on top of the binomial. And so you get minus negative 6x squared minus 2x. Okay, do the subtraction. Negative 6 take away negative 6 is going to be 0x squareds. 1 take away negative 2 is going to be 3x. Bring the 11 down. Okay, and we got one more to do. 3x into 3x is going to be plus 1. And then distribute again, okay? So minus 3x plus 1. Oh, I made a mistake. One sec. I carried the wrong thing down. I was worried. So I know what the remainder is. That's what's kind of handy about this. When you do the division, you can catch some errors, right? What did I do? I messed up. It didn't carry the negative. I made it positive. So that needs to be fixed. Okay, so that's minus. Oh, that was the plus 1 though. This is going to be minus 11. So minus 11, take away one more, is going to be the negative 12 we're looking for a remainder. Okay, and so if I were to write this in a quotient now, right? So basically, I'll write it maybe as slightly different, but same thing. 4x squared minus 2x. I'll write it the same way. Plus 1 plus, or I guess in this case, minus 12 over what I originally divided by, which would be 3x plus 1. If I took all of that and I multiplied it by 3x plus 1, I would get back out the original polynomial of 12x cubed minus 12x squared plus x minus 11. Okay. And then the restriction is that cannot be equal to 0, and so 3x cannot equal negative 1, and subsequently x cannot equal negative 1/3. Okay, so that's it for number 1b.